In our modern world, there's this powerful hidden engine that keeps everything flowing. We're talking about the water in your tap, the fuel in our cars, pretty much everything. It's a piece of tech that's so fundamental, it's basically invisible. So today, we're going to pull back the curtain and take a look. All right, so let's just jump right in with a huge question. Really think about the scale of modern industry for a second. How do you actually move a river of crude oil across an entire continent? Or how do you push millions upon millions of gallons of water to every single tap in a city? You can't just, tip the tank over? No way. The scale is just massive. And the answer? Well, it's so simple, but its impact is just monumental. You use a pump. This machine is the true, unsung heartbeat of industry, beating away day and night to move the fluids that our entire civilization runs on. Yeah, and we're not just calling it a heartbeat for fun. Think about it. If a critical pump goes down in a chemical plant or a refinery, production doesn't just get slow, it grinds to a halt. And get this, pumps chew up a staggering 20% of all the electrical energy used by industry worldwide. That's huge. So when one fails, you're not just looking at shutdowns and lost money, you're looking at potentially serious safety hazards. Reliability isn't just a nice to have, it's absolutely everything. Okay, so what exactly are these things? Well, even though there are thousands of different kinds of pumps out there, they pretty much all fall into two main families. And understanding this one big difference is really the key to getting how they all work. This table lays it out perfectly. On one side, you've got dynamic pumps. Think of them like a slingshot. They use speed, just flinging the liquid to create momentum and pressure. You get a really high flow rate, but the pressure can kind of vary. Then you've got positive displacement pumps. These are way more like a syringe. They trap a specific, fixed amount of fluid and just force it out. This gives you a really steady, constant flow and can build up some seriously high pressure. It's perfect for thick stuff or when you need exact amounts. So two different tools for two very different jobs. Now, both of these families are super important, but we're going to zoom in on the undisputed king of the dynamic pumps, the centrifugal pump. Why? Because this thing is the workhorse of industry, by far. So let's pop the hood and see what makes it tick. So let's break this thing down. You've got four main parts. First is the impeller. That's the spinning heart of the whole operation. It sits inside the casing, which is this specially shaped shell that's key to building up pressure. The shaft, well, that's just the rod that connects the impeller to the motor. And then you've got the mechanical seal, which is absolutely critical for stopping the high-pressure liquid from leaking out all over the place. And here's how it all comes together. That slingshot for fluid analogy, it's perfect. Okay, so first, the liquid gets sucked into the middle, the eye of that spinning impeller. The vanes on the impeller catch the fluid and just sling it outwards at a crazy high speed. This super fast fluid then smacks into the wall of that snail-shaped casing, which we call a volute. And because the casing gets wider, the fluid is forced to slow down. And just like that, all that speed, that velocity, gets converted into force. In other words, pressure. It's really that simple. But, this whole elegant process has a major weakness, a really nasty enemy that can just tear a pump apart from the inside. It's a phenomenon that every plant operator learns to spot and, frankly, to fear. It's a word that every operator knows and dreads: cavitation. When you talk to the folks who work with these machines every day, they have a really vivid way of describing it. They say it sounds like you're trying to pump a bunch of gravel or marbles. It's this loud, grinding, violent noise. And it's just a deeply wrong sound to hear coming from a machine that's supposed to be humming along nice and smooth. So what in the world is going on here? Well, if the pressure on the way into the pump drops too low, the liquid can actually start to boil. Not from heat, but from low pressure. This creates tiny little vapor bubbles. As these bubbles get swept into the high-pressure part of the pump, they collapse, and I mean collapse violently. And each one of these collapses is like a tiny, microscopic explosion, a little hammer blow right on the metal. Now imagine millions of those happening every second. They will literally eat away at solid steel. Okay, so how do you fight this thing? It really all comes down to knowing what to look for. An experienced operator, they know the signs. If they hear that awful noise and feel the pump start to vibrate, they're immediately thinking low suction pressure, and the first thing they do is check that the suction valve is wide open. If they see on the gauges that the flow and pressure have suddenly dropped, they suspect a blockage, and they're going to check the strainer on the suction line. It's all about connecting that symptom to the cause and acting fast. And that really brings us to the most important part, the human element. These incredibly powerful machines don't just run themselves. It's the skill, the knowledge, the discipline of the operators that keeps these things running safe and sound and prevents a total disaster. And they live by a few golden rules. They might sound simple, but they are absolutely non-negotiable. Number 1, you've got to prevent cavitation. So always make sure there's plenty of liquid getting to the pump. Number 2, never ever start the pump against a closed discharge valve. They call it deadheading. All that energy has nowhere to go, and it will literally destroy the pump from the inside out. It's a huge no-no. Third, you have to listen to your machines. Seriously, your ears are one of the best tools you have out there. And last but most important, safety first. Before anyone ever lays a hand on that pump for maintenance, it has to be lacked out and tagged out, no exceptions. So, at the end of the day, it's not just about the fancy engineering of the pump itself. It's about this vital partnership between these powerful machines and the sharp, skilled people who run them. It's that partnership, that synergy, that's the real engine powering our world. Kinda makes you think, doesn't it? From the moment you woke up this morning and turned on a faucet to the car you drive, these hidden heartbeats are just everywhere, working away. So, what other invisible machines are out there, right now, powering your day?